What if something entering our solar system right now isn't just a stray rock from the stars, but something far more advanced? Astronomers recently detected an interstellar object known as 3I/Atlas, a massive body hurtling through space at over 120,000 miles per hour. On the surface, it seemed like another cosmic visitor, much like Oumuamua or Borisov. But soon, scientists realized that nothing about it made sense. Its size, speed, and trajectory defy the rules of physics we've come to rely on. Then, just as it passed near Mars, something strange happened, a sudden blackout in NASA's data streams. Officially, it was blamed on a government shutdown. But the timing raised eyebrows across the scientific community. Now, experts like Dr. Michio Kaku warn that what we're seeing might be more than a natural anomaly. Could 3I/Atlas be a technological artifact, something built, not born, in the cold dark between the stars? In this video, we'll examine the clues, explore the evidence, and uncover why this mysterious object could become far more dangerous than NASA or anyone expected. Because if the data we're missing reveals what some scientists fear, this could be the discovery that changes everything we know about life in the universe. When 3I/Atlas made its closest pass to Mars, astronomers around the world were preparing for a historic moment, the first chance to study an interstellar object up close since Oumuamua. Telescopes were ready, instruments calibrated, and every data stream was set to capture high-resolution images, temperature readings, and chemical analysis. Then, in a twist straight out of a science fiction movie, everything went dark. NASA's live feeds, telemetry updates, and raw data channels all went offline at the exact moment of closest approach. The official explanation: a temporary government shutdown that disrupted non-essential services. On paper, that made sense, until scientists in Europe, Japan, and South America began reporting the same thing: broken data links, corrupted files, and gaps in their synchronized observations. To many, it felt less like a coincidence and more like a deliberate blackout. The question was, why? Some researchers suggested it might be a technical issue, an overloaded system, or an unexpected solar flare interfering with communication. But others weren't convinced. The timing was too perfect, the silence too complete. The missing data covered precisely the window when 3I/Atlas was closest to Mars, the point where we could have determined its shape, density, and composition with the greatest accuracy. When the feeds finally came back online, the moment had passed. What little information was recovered painted a strange picture, an object that looked stretched, shrouded in a faint, unnatural glow. Not a comet tail, not a dust plume, something different. Whether the blackout was coincidence or cover-up remains unknown. But one thing became clear. This object doesn't behave like anything we've ever seen before. And the fact that our most powerful space agency went silent exactly when answers were within reach has left scientists, and the public, asking a question NASA still hasn't answered. What are they not telling us about 3I/Atlas? When the first clear images of 3I/Atlas finally emerged, astronomers expected to see something familiar: a dusty comet with a bright icy tail, glowing from solar radiation. What they found instead left experts speechless. Unlike any comet or asteroid we've ever observed, 3I/Atlas appears to be stretched and elongated, almost like a metallic spindle or a flattened cylinder drifting silently through the void. It's eerily similar in shape to Oumuamua, the first known interstellar visitor, another object that defied every conventional model when it appeared years earlier. But that's only the beginning. 3I/Atlas shows no visible tail, no radiant stream of vaporized ice, and no signs of the intense outgassing typically triggered by sunlight. Instead, it's surrounded by a hazy, ionized cloud, a faint envelope that doesn't behave like normal gas or dust. Scientists describe it as a light-absorbing shell that reacts strangely to sunlight, absorbing and re-emitting energy in ways that don't match any known physical models. Some researchers have proposed that this cloud could act like a natural shield, protecting the core from radiation or micrometeor impacts. Others, more boldly, wonder if it's something engineered, a form of energy barrier or plasma field, possibly designed for long-duration interstellar travel. Its surface brightness also fluctuates unpredictably, suggesting complex internal structures or materials with reflective properties far beyond our understanding. To make matters stranger, the object's rotation rate doesn't match its shape. It spins too smoothly, too evenly, another sign that its mass and internal composition might be anything but natural. Whatever this thing is, it doesn't look or behave like a simple rock tumbling through space. It seems designed, or at the very least, maintained by forces we don't yet understand. And if that's true, then the real question isn't what 3I/Atlas is made of, but who, or what, could have made it. If 3I/Atlas had simply drifted into our solar system from a random direction, it would have been fascinating, but explainable. Interstellar objects are expected to enter at unpredictable angles, like cosmic debris wandering aimlessly between stars. But that's not what happened here. 3I/Atlas is following an almost perfect alignment with the orbital plane of our solar system, the same flat, invisible disk on which all our planets travel around the Sun. In simple terms, it's flying directly along the superhighway of our planetary system, within just 5 degrees of Earth's orbit. According to astrophysicist Dr. Avi Loeb, the odds of this happening by pure chance are astronomically low. Most interstellar travelers come from above or below that plane, passing through like stones skipping across water. Yet 3I/Atlas is moving with the flow, as if it knew exactly where the planets would be. And it gets stranger. Its path isn't a random flyby. The object's trajectory will carry it past Mars, near Jupiter, and then outward again, as though it's following a pre-calculated route through our system. From an engineering standpoint, this is the exact kind of trajectory you'd design for a multi-planet survey mission, efficient, precise, and deliberate. Even more intriguing, this alignment places 3I/Atlas in what scientists call the prime detection zone, the same vantage point we use to discover exoplanets. From this angle, any civilization along that orbital plane could observe Earth passing in front of the Sun, instantly identifying it as a living, habitable world. So, was this an accident? Or was 3I/Atlas intentionally placed on this path, perhaps by someone, or something, that already knew we were here? If this trajectory truly is deliberate, then 3I/Atlas might not just be visiting us by coincidence. It might be coming exactly where it intended to go. Every interstellar object we've ever studied follows the same basic rules of physics, until now. 3I/Atlas doesn't just bend those rules. It shatters them. Scientists have identified 7 anomalies that make this visitor unlike anything we've ever seen before. Anomaly number 1, impossible mass. Based on orbital measurements, 3I/Atlas could weigh as much as 73 trillion pounds, over 6 million times heavier than SpaceX's Starship rocket. Yet, despite venting gases and dust, its course never changes. Normally, this outgassing acts like tiny rocket thrusters, nudging comets off path. But here, nothing moves. The mass, or perhaps the control, is beyond explanation. Anomaly number 2, no smaller companions. If nature can create something this large, we should see thousands of smaller fragments from the same region of space. But telescopes have found nothing. Not one smaller object, no debris trail, no parent cluster. It's as if 3I/Atlas was made, not born. Anomaly number 3, alien chemistry. Spectral readings reveal cyanide and carbon monoxide, common comet chemicals, mixed with complex silicates, the kind found on rocky planets, not frozen interstellar ice. It's like a fragment of a world, not a comet nucleus. Anomaly number 4, extreme resilience. In late 2025, a powerful solar storm blasted directly into 3I/Atlas. Scientists expected fragmentation. Instead, it absorbed the hit and continued on, unchanged. Almost as if it was built to survive. Anomaly number 5, reversed light polarization. When light bounces off dust, it polarizes in predictable ways. Every comet we've ever seen shows positive polarization, except this one. 3I/Atlas displays a strong negative polarization, meaning its particles are made of something unknown, possibly engineered materials. Anomaly number 6, engineered trajectory. Its path through Mars and Jupiter isn't random. Mathematically, it mirrors what you'd design for a flyby mission, maximizing planetary encounters while conserving energy. Anomaly number 7, elongated shape. Gravity naturally rounds objects over time. Yet 3I/Atlas is long and thin, an inherently unstable shape for a natural body, but ideal for interstellar travel, reducing collisions with debris. Individually, each anomaly is strange. Together, they form a pattern, one that whispers of design, purpose, and possibly, intelligence. What if 3I/Atlas isn't a rock at all, but a Trojan horse drifting silently through space? Some scientists have begun to ask that very question. If an advanced civilization wanted to explore the galaxy without alerting other intelligent species, what better disguise than a comet, something so common that no one would suspect it? The Trojan horse hypothesis suggests that 3I/Atlas could be an ancient probe, cloaked in debris and dust to appear natural while performing its mission. Its strange mass, flawless trajectory, and extraordinary resilience would make perfect sense under that light. Instead of being pushed around by outgassing like a normal comet, it seems to hold its course with mathematical precision, almost as if it's steering itself. Its 5-degree orbital alignment with the planetary plane might not be random either. From that position, it can easily observe multiple planets, gathering data on atmospheric composition, magnetic fields, and, most intriguingly, signs of life. That's the exact observation path human engineers would design if we were the ones sending a probe into another star system. Then there's its light polarization and ionized cloud, behaving almost like a field of charged particles, possibly a protective layer against radiation or dust impacts during deep space travel. The idea sounds like science fiction, yet every measurable feature of 3I/Atlas seems to lean toward intention rather than coincidence. Supporters of the Trojan horse theory argue that this could be part of a larger network, millions of probes released by an ancient civilization, silently mapping the stars for eons. Each one would look harmless, almost indistinguishable from a comet, until careful observation reveals the subtle differences. If true, 3I/Atlas wouldn't be the first of its kind, only the first we've noticed. Its design would be the ultimate camouflage: hide a tree in a forest, hide a probe among comets. And if that's really what it is, then maybe it's not just passing through. Maybe it's been watching us for a very long time. Not everyone believes 3I/Atlas is artificial. While some see evidence of engineering, others argue it could be a natural phenomenon of cosmic proportions. Something so rare that it simply appears alien because we've never witnessed it before. Enter the planetary seed hypothesis, proposed by astrophysicist Dr. Suzanne Pfner and other researchers who study the birth of worlds. Their theory suggests that massive interstellar objects like 3I/Atlas might act as planetary cores, carrying the raw materials and gravitational density needed to jumpstart planet formation around young stars. In essence, these seeds could be the universe's way of planting planets. Instead of starting from microscopic dust particles that take millions of years to grow, a single giant interstellar body could accelerate the process, forming entire worlds in a fraction of the time. According to simulations, if an object like 3I/Atlas were ever captured by a newborn star system, its immense mass could serve as a foundation around which other matter collects: gas, rock, ice, eventually giving birth to new planets. In that sense, Earth itself could once have originated from a visitor just like this, billions of years ago. If that's true, 3I/Atlas might not be a threat at all. It could be a builder, not a destroyer, a remnant of the same cosmic process that gave rise to our own world. However, that doesn't erase the mystery. Even under this natural model, its behavior remains hard to explain, its shape, its resilience, and its precise alignment with our orbital plane still defy probability. Could nature really craft something so perfect, or is this theory simply an elegant way to make the unexplainable feel safer? Whether it's a planetary seed or an interstellar probe, 3I/Atlas challenges us to reconsider everything we thought we knew about cosmic creation. And as it speeds toward its next encounter, a close pass by Jupiter in 2026, the line between science and speculation is becoming thinner by the day. As 3I/Atlas races through our solar system, one thing has become clear: it's accelerating. Current measurements show it moving at over 82,000 miles per hour, and it's expected to reach nearly 100,000 miles per hour as it approaches the Sun. That acceleration, combined with its immense mass, means that if anything were to alter its trajectory, even slightly, the results could be catastrophic. Right now, there's no sign of a collision course with Earth or any other planet. But comets are unpredictable. They can fracture, eject gas, or change direction without warning. And when you're dealing with something this massive, even a small deviation could create a chain reaction across the solar system. With NASA's data blackout still casting doubt on earlier observations, attention has now shifted to the European Space Agency. While American systems went silent, Europe's Mars Express and Trace Gas Orbiter continued collecting data. Their readings suggest 3I/Atlas emits faint but consistent energy signatures, signals that might finally reveal what lies beneath its strange ionized cloud. The next big opportunity comes in November 2025, when the JUICE mission, originally built to study Jupiter's icy moons, is expected to cross paths with 3I/Atlas's trajectory. If its instruments detect unusual heat, electromagnetic fields, or artificial geometry, it could be the breakthrough moment the world's been waiting for. But there's a catch: time is running out. After December 2025, 3I/Atlas will make its final close approach to Earth, at a distance of about 167 million miles, before vanishing into deep space forever. Once it's gone, our window to study it, and to find answers, will close permanently. Across the globe, telescopes are being retasked, observation schedules rewritten, and international teams formed in a race against time. For scientists, this isn't just another interstellar mystery. It's a once-in-history opportunity to understand whether we're witnessing the birth of a planet, or the passing of something built by intelligence far beyond our own. The countdown has already begun, and every passing day brings us closer to the truth. As the world watches, 3I/Atlas moves closer to the heart of our solar system, and closer to the unknown. Its light grows brighter, its tail stretches longer, yet behind the beauty lies something deeply unsettling. We still don't know what it is. By early December 2025, 3I/Atlas will reach perihelion, its closest point to the Sun. For astronomers, this is both the most dangerous and the most critical phase. The intense radiation could strip away its outer shell, revealing what lies beneath, or it could destroy it completely, taking every secret with it into the void. Space agencies around the world are on high alert. NASA, ESA, JAXA, and even private observatories are synchronizing telescopes to record every moment of the encounter. Yet there's growing fear that 3I/Atlas is already fading irregularly, pulsing in brightness as if something beneath its surface is reactivating, or failing. Meanwhile, online forums and independent astronomers have begun reporting a strange phenomenon: radio noise bursts at intervals that appear almost rhythmic, too structured to be random cosmic static. Could it be interference from solar wind? Or could 3I/Atlas be transmitting something, a final data burst before leaving the system forever? Governments have remained silent, fueling speculation. A leaked internal report allegedly warned of controlled deceleration patterns, suggesting the object might not simply be coasting through space, but adjusting its path deliberately. If that's true, then everything changes. As 3I/Atlas approaches the Sun, we are standing at the edge of a cosmic revelation. Will it crumble like a comet, confirming our natural theories? Or will something impossible emerge from the light, proof that we are not alone? Whatever happens next, one thing is certain: after perihelion, 3I/Atlas will vanish into the darkness beyond Jupiter. And when it does, humanity will be left with only the data, the questions, and the haunting realization that something from the stars found us first. The countdown is nearing zero. And soon, the skies will decide whether we're witnessing a miracle of nature, or a message from the void. When 3I/Atlas finally vanishes into the darkness, humanity will be left staring at an empty patch of sky, but forever changed by what it revealed. For the first time, we've witnessed an object from another star system that refuses to play by the rules of nature as we understand them. Whether it's a planetary seed, an ancient probe, or something beyond our comprehension, 3I/Atlas forces us to confront one undeniable truth: we are not the center of the universe's story. For generations, we've looked outward, asking if someone, or something, might be looking back. 3I/Atlas reminds us that the answer might not come in the form of a signal or a spacecraft, but in the quiet passing of a single, mysterious visitor. Scientists will spend decades analyzing the data gathered during its brief encounter with our solar system. Its trajectory, composition, and radiation patterns will become case studies, shaping how we search for other interstellar travelers in the future. Missions are already being proposed: autonomous probes that could intercept future visitors, equipped to scan, sample, and record every secret before they slip away. But beyond the science lies something more profound: the philosophical legacy. 3I/Atlas challenges the way we define life, intelligence, and purpose. It reminds us that not everything unknown is dangerous, and not everything familiar is safe. Sometimes, mystery itself is the message. As it fades into the cosmic night, perhaps it carries with it fragments of our observation, light reflected from human telescopes, radio waves from our questions, echoes of our curiosity traveling with it across the stars. Maybe one day, somewhere far beyond our reach, another civilization will see that reflected glimmer and wonder, just as we once did. 3I/Atlas came without warning, and it will leave without goodbye. But its passage marks a turning point, a reminder that the universe is alive with motion, intelligence, and wonder. And as the darkness closes behind it, one thought lingers above all. Perhaps we were never alone. Perhaps, we were simply waiting to notice.